Hi there. Hello, everyone. Welcome to Code Conyo. For today, we're going to talk about matrices and matrix operations. So, when we talk about matrix, it is a rectangular arrangement of numbers into rows and columns. And when we work with matrices, we refer real numbers as we refer to real numbers as scalars. So an n times m matrix is called a square matrix if and only if both matrices have equal number of rows and columns. So you have here an example of matrix, which is a 3 by 2 matrix. So we have here the 3 number of rows and we have 2 number of columns. So we often denote or we use the notation A is equal to A subscript I and J for matrix, and we often use capital letters to represent matrices and enclose the array of numbers with using brackets or parentheses. So we do not use simply straight lines in place of brackets when writing matrices because the notation has a special meaning in linear algebra. So this one right here, we have here A is equal to A subscript ij. This is a shorthand notation often used when we want to specify the how the number of elements or how the elements are to be presented or represented. So where the first subscript I is denoting the row number, and the J subscript is it's going to denote the column number of the entry A subscript I and J. Thus, if we are going to write A 25 or A subscript 25, then we referred it as 2, or the first subscript is the element in the second row, and the the entry is at the second row and at the fifth column. So this notation, however, does not indicate the dimensions of the matrix. Okay, so let's say for an instance we have here 4, 9, 7, -3, 2, and 8 in a 3 by 2 matrix, and we want to know the first the row, the matrix 0, 1. So that is actually 9. So basically 0, 0. So row 0 and column 0 is 4. Row 0 and column 1 is 9. Then row 1, column 0 is 7. Then row 1, column 1 is -3. Then row 2, column 0 is 2. And then row 2, column 1 is actually 8. So um, matrices have many applications in discrete mathematics. You have probably encountered them in a pre-calculus course. So we represent the basic definitions associated with matrices and matrix operations here, as well as a few additional operations with uh, which you might not be familiar. So these are the applications of matrices. So we have solving systems of linear equations. We have computer graphics, image processing into games, models with many areas of computational science and engineering, quantum physics, quantum mechanics, and quantum computing, and many more. So how about the row and column order of matrices? So basically, as I've told you earlier, the matrices, we use this notation to represent our matrix. So we have A subscript I and J, where I is the row and J is the column. So when we have this numbers, or we have these elements in our matrix, so this is basically a 1, so 1 2 3 4, and 1 2 3 4. This is a 4 by 4 matrix. So basically this number 3 is located at row 0 and column 0, and 5 is located at row 0, column 1. So row 0, column 2 is 7, and row 0, column 3 is 9. And then for row 1, column 0, we have 4, and row 1, column 1 is actually 10, and so on and so forth. So I guess that's it for now, and we're going to continue our discussion about matrices in the implementation of uh, programming concepts using Java language. So thank you guys for watching this video, and see you later. Bye bye.